Alright, so with a little technical difficulty, this first slide is going to be kind of backwards. Basically, yeah, see, it's writing from where I finished writing. Okay, disregard all this, let the full screen come up, but I'll go ahead and kind of start explaining it. Basically, you're only going to have a slant asymptote if the degree, meaning like x squared, the degree is higher on the top than it is on the bottom. So in this case, we have an x squared over an x. So that qualifies us to have a slant asymptote. So what we want to do to find the slant asymptote, once this all fills in here and is not, backwards, basically what we want to do is divide the bottom, or the top by the bottom, right? We're going to actually do the long division here. So we have x minus 3 on the bottom. We're going to put that inside of, or basically dividing that into x squared plus 5x plus 4. And so when you put this, you're basically saying, okay, what do I got to do to get to an x squared? Well, if I multiplied by an x, then I'd get an x squared. So that's why I have this x up here. So then we go back through and multiply it out. So x times x gives us x squared, and x times a negative 3 gives us a negative 3x. And just like in regular long division, you have to subtract these. So that's what I do there. So then positive 5x minus a negative 3x gives us this positive 8x. Okay, and then from there I'd have to multiply by an 8 in order to get that 8x, so that's where this 8 comes in. So then I go ahead and multiply back through. 8 times x gives us this 8x here. 8 times negative 3 gives us that negative 24 there. And this is pretty much where we're done. We don't even really need to subtract those, but basically our slant asymptote is going to be this equation here, okay? Alright, sorry for the confusion on that. Hopefully you're able to figure it out. Let's go ahead and move on to number 89. Okay, so let me see here. Let me find it in the pictures you sent me. Alright, number 89. So we basically have, some function that represents, some drug potency. I've graphed the function here, and the first one is what is the highest concentration of the drug that is reached in the patient's bloodstream. So I just used some sort of graphing calculator, or I plugged mine into the web, online. So this value here is actually 5/2. So, and where does that occur? It occurs at t equals 1. And you can just see that by plugging that in online or on a graphing calculator. You're looking for what the maximum is there. And then for B, basically what happens to the drug concentration after a long period of time. So we're saying, if we were to plug in a really big number there into t, we'd get some sort of somewhat big number on top and then an even bigger number on the bottom. It's kind of hard to maybe imagine, but if you were to plug in 1 million for t, you'd have 5 times 1 million over 1 million squared, which is way bigger than 5 times a million, meaning that our denominator is way bigger than our numerator. So this thing kind of gets really, really small. So, for actual good answer for B, what happens to the drug concentrate after a long period of time? After a long period of time, the drug concentration is, diminishes to 0 almost, basically gets really low and is no longer present in the body. Alright. And sorry, I think I skipped the C on the last one. Basically, you just want to see, what time for t. Oh, here we go. So we're just solving for t in this case because we want to see when that whole thing will be bigger than 0.3. Alright, so
go ahead and just kind of solve for that. Alright, cool.
Right, and so basically the reason to set it up like that is, we want to see when this concentration is below 0.3. So that's why I say 0.3 is bigger than this stuff, because we want to know when this stuff is going to be smaller than 0.3. Should use a different color. This stuff here, we want to know when that will be less than 0.3. So I literally just set this up here. I set that up and then go ahead and solve for t. Okay, I ended up getting to this stage right here, and then remember that x equals negative b plus or minus the square root b squared minus 4ac all over 2a. You'll basically just kind of have to plug these a, b, and c into that formula. And that will give you t values. And then you can say, okay, when t equals this, then that's when the function is less than 0.3, or that's when the concentration is less than 0.3. Alright, so number 90, this one's not too bad. You just kind of have to think about, okay, so this is, some flight of the rocket. A vertical asymptote is some point where, if this is a graph, and we have a vertical asymptote here, that means that we can't have this x value all along this line, whatever x value that is, like x equals 3 or something. So basically, the vertical asymptote would represent a velocity because, well, what is x, or, in this case, it's v. Well, v measures velocity, so basically, a vertical asymptote is a place where we can't have that velocity. So it represents a velocity that we can't obtain. That's the best way I'd describe it. Cool. Alright, so the next couple of videos you'll have 3.7. So this wraps it up for 3.6. Let me know if you have any questions. Thanks.